even though we spent a little time on the absolute value equations last week, I want to go back and spend a little more time on the compound inequalities. There were two types, and ors. What I found is that we're getting really good at solving equations and inequalities, but be careful to read directions. On our last quiz, you were asked to solve and graph and show your work. You start to lose credit when you don't do all of the above. So let's take a look at some compound inequalities. We'll start with the ends. When I look at a compound inequality, it's basically just two simple inequalities connected to each other. In the first type, you'll notice that your variable is in between two inequality symbols. That's going to tell us that we need to isolate the variable from the inside. So we're going to see subtraction, so we will add, being very careful that we use the inverse operation. Negative 3 plus 6 will give me 3. That tells me 3 is less than x. Now we've isolated x, which is less than or equal to negative 1 plus 6 is 5. When we go to graph this, remember we generally graph an inequality from starting with the variable. So if I look at this as two separate inequalities, the first inequality, writing the variable first, would be x is greater than 3. And because there's two parts to this one, and the variable's in the center, the second part says x is less than or equal to 5. Another thing to be very careful of is those circles on the number line. X is greater than 3, so at 3 there's an open circle because there's no line underneath. Whereas at 5, I'm going to have a closed circle because it's also equal to. Because it is a solution where x is greater than 3 and less than or equal to 5, my solution falls within this section. Again, it includes 5, does not include 3, so everything greater than 3 but less than or equal to 5. Here's an example of a two-step. Once again, look inside the center of this expression or this statement. I'm going to start by adding 1. That gives me 6 is less than or equal to 2x, which is less than 12. One more thing to do because I need to get x alone. I'll divide all parts, the left, the right, the center, by 2. And now I have an inequality that says 3 is less than or equal to x, which is less than 6. Again, I could write this as two separate inequalities. This is my first one, so again, starting with the variable first, if 3 is less than or equal to x, x must be greater than or equal to 3. And second part, x is less than 6. So again, I need a circle at 3. This time it's a closed circle. Why? Because of this line underneath that says it's also equal to that solution. And then I go to 6, which again my graph does not have, so I'll just add a 6 right here. That would be an open circle, and I'd shade everything in between. The ands join together. They meet up. It's this and that together. The second type of compound inequality was the ors. And you're going to solve two separate simple inequalities and then graph them on the same number line. In the first, I'm going to add 1, and I get x is less than 2. Or, and again I need to include that word or, I'm going to subtract 1 on both sides and divide by 2, and I'll get x is greater than 4. So on my number line, I'll locate 2. This one is an open circle, and it says that x is less than 2, so that's shading everything in the less than direction. The second part says, let's put a circle at 4, and once again an open circle, and it's shading everything greater than, so it goes to the right. So in an or, you have your solutions going in opposite directions. Let's just look at one last additional problem here. In the first, I'm going to subtract 2 to isolate my variable. So I have x is less than negative 2. Or, there's one more part, let's add 3 to both sides. X is greater than 4. So once again, these both have less than or greater than symbols, so they're open circle. I'll start at negative 2, open circle, and shade everything less than negative 2. Doesn't include negative 2, just everything less than. Then let's find 4 in our number line, open circle, and this statement says that x is greater than 4. So if I asked to test out a solution, I could pick any number to the left of negative 2 or to the right of 4. And those are our compound inequalities. It's very important to know how to graph them. And we have to remember, and again, looking back to some common mistakes on our last quiz, if you're faced with, in a simple inequality, something like negative 5x is less than or equal to 25, if I'm dividing by a negative, you must reverse the direction of your inequality as you're solving in order to make that true. If you're solving an inequality and your variable is on the right, so if I have 12 is less than, say, x minus 4, I'm going to add 4 to both sides. And I'll get 16 is less than x. So again, we reverse it because if we go to graph this, we're probably going to graph incorrectly. So remembering when to reverse your inequality symbol. When you multiply or divide, again, I could have something like this. I would multiply both sides by a negative 2. When I'm multiplying by a negative, I reverse the direction of my inequality. So multiply or divide by a negative tells me to reverse if my variable is on the right. I also do the interchange and I reverse. Key things that apply to both the simple and the compound. And then in our last class, we had our introduction to absolute value equations. Remember, we need to solve them twice. When I looked at the homework, some of you solved once, some of you were not sure. Always go back to the video and revisit the lesson if need be. I've got x minus 5 is equal to 6, and then I'm going to have x minus 5 is equal to negative 6, because what fits in this absolute value symbol could be 6, and it could be a negative 6. So I want what it fits in here to be equivalent to one of those two numbers. So I'm going to add 5 to both sides. I get x is equal to 11, one possibility. And my other is to add 5 once again, but this time I have negative 6 plus 5, so x is equal to negative 1. I will get two solutions when I'm solving absolute value equations and inequalities, which we probably will not get to today. I'm going to take away the symbol and solve it once. And again, I'm going to do the same thing now with a negative 5. 2x minus 3 equals negative 5. I will add 3 to both sides. I'll get 2x is equal to 8. So x is equal to 4 is one solution. I'll add 3 to both sides. I'll get 2x is equal to negative 2. The last step says to divide. X is also equal to negative 1. If we substitute them in, we're going to see that we get the right answer. Let's just try two more before I do something different. X plus 4 equals 6. Let's subtract 4 on both sides. X could be equal to 2 because 2 plus 4 is 6, and the absolute value of 6 is 6. Let's go to the second part of this, where we change that sign that it's equal to the negative. And I'm going to subtract 4 on both sides, and I get x is equal to negative 10. Well, negative 10 plus 4 is a negative 6, and the absolute value of negative 6 is also 6. So you see that two numbers do work out. Could be a two-step, 3x plus 1 equals 13, and 3x plus 1 equals a negative 13. Try that one. And then in class, we're going to look at some that have operations on the outside, and we want to eliminate the operation first. We'll do those in class. Well, actually, I'll do one now before. This way, in case you need to revisit the video, there's one there. When there's an operation outside, I need to eliminate that first. That means I'm going to subtract 2 on both sides. Now that I've subtracted that 2 and I'm left with the absolute value expression, that's when you can go ahead and solve twice. You need to always remove anything attached on the outside of the absolute value expression before you go and solve. We'll do more in class.